Hello, in this video I will do the conversion from Makefile to CMake of this audio dev kit. For a description of what this kit is and how to get it up and running, please see the other video. I chose this project as an example because I think it's representative of many of the projects you are dealing with. Simple, not many files, and I think regardless of what CPU vendor you're using, this will cover most of the basics. Quickly, why do I like CMake and why do I think you should use it? So real-world projects will get complicated. You'll have multiple targets for unit testing, for compliance testing, all sorts of one-off targets. They'll all share some stuff, but they'll have some unique stuff. I like how in CMake the target and the list are first-class citizens, which allows you to view and operate on the build system at a higher level. Human-readable diffs, again with the complexity thing, it's also important visually to reduce fatigue and friction for the programmer. Build systems are source code, not some one-off script. If you don't like the idea of business-critical and system-critical logic living inside bash scripts, I think makefiles are analogous. Which is why the declarative style works here. Let the generated makefile be as ugly as necessary. Remember that a lot of portability issues are being handled for you, and some of the CMake operations are complicated. I don't care how it gets done, since at the end I can just look at the actual compiler invocations if I need to double check. Okay, let's get started. So here I have the project open. Let's quickly look at what we have to start with. These are the files here. We have the STM32 libraries, the linker script, startup files, Cortex M4 files, and the application consisting of main, the audio delay application, the codec, etc., and the makefile here. The makefile is quite simple. It just specifies the object files, the linker script, compiler flags, and the toolchain. Then we have some make targets for flashing, but ultimately we are just interested in this main.elf here. Run the makefile is pretty straightforward. We're just calling GCC, it calls the linker, and then object copy, all very straightforward. So let's get started. So making a build directory as is standard. We have an empty CMake lists, and we build, and it does nothing, as expected. So let's put this in a loop. Okay, so first it wants us to specify a project name and CMake minimum required. Let's go ahead. Minimum required, version 3.0, project, target name. So I'm going to be using a lot of setting variables, which I know is not the modern way to do it, but it's simple for now. I want to start with the object files. This is what we're going to build. So we'll do a quick operation here. Replace space with new line. So I'm going to set my C sources to this list, and also I want to change the .o's to .c's, except the startup, which is a .s. And then I want to say that I want an executable to be built with the following name, consisting of the following C source files. Okay, so we see CMake generated the makefile and is attempting to build this C file here, and it can't find the header here. So notice we have the make verbose equals 1 option, and this is telling us the whole story of what's happening. So see here, we are not specifying any include directories. So to do that, I'll say include directories and just the current directory. Now it says cannot find the armcm4.h inside of the armmath.h. So let's see what's going on there. Armmath is looking for here cm4 Now we see these are some preprocessor conditionals based on the symbols that are defined, and we haven't defined any. It's funny, this warning I think should be above the including, so we actually get to see the warning. Right, so now we can see in the Makefile those symbols are there. So to specify the symbols here, I'm going to make another variable, CFlags. And this is one of the reasons not to use these variables here, because here, this is actually not a list, this is just a string, which I'm appending to, and because of that, I'm going to have the leading and trailing spaces. So this is all basically one long string, which will be passed into the compiler. And then I'm going to say my CMake CFlags. So this is the internal CMake variable. I'm going to set that to the value of my CFlags. Okay, there it goes. Keeps going. Now it's looking at some inline assembly, which it doesn't recognize. Yeah, the C file here has inline assembly. That must be because we're using the wrong compiler. We don't want to use CC, we want to use ARM GCC. So we need to specify the toolchain. So to do that, I'm going to say set a toolchain directory bin, that's where it is. And looking it up here, we can see CMake toolchains are specified like this, where we have C compiler here, which will be toolchain dir, and we want ARM non-GCC, and it continues. This processor does not support these instructions in ARM mode, so we have to get a little more specific. So let's just add all these ARM related flags. Add the spaces. So we'll say string append my CFlags. And here we have the classic unrecognized command line option, R dynamic. This is a CMake issue. If you Google around, basically this is the workaround. So CMake is assuming that we want the R dynamic flag, but we actually don't. So we're going to say do not have any flags. Now we have undefined reference to exit. So it's trying to link in the system calls, and we don't have any because this is bare metal. So here we're going to say no start files. Okay, it goes again. Cannot find entry symbol start. So it sounds like it's not using our linker script. So I will add that. And just for simplicity, we're combining the linker flags with the compiler flags, but that's fine. For now, this is the linker script. And it says, one more time, it says no such file. Just try going up a directory. Never remember where the current directory is. Okay, so now it can't find the reset handler, which is defined in our startup code, so somehow it's not doing anything with this. I think that's because we haven't set the ASM compiler to that. And does it like that? It does like that, so we have something. It's 17,000. Now let's compare it to the original, which is 8,000. So not exactly right. Now at this point, I would just make sure that everything else is the same from the original. So I have these optimization flags. that, the -G. Okay. Still cannot find. Okay. So maybe I'm gonna say here enable language ASM. Okay, that looked a little better. Okay, now we have 8872. Elf 8872. These are exactly the same sizes, but anyway, so this is it. And of course, this is a little messy with the flags. Of course, eventually you'll be changing this, but this is a good starting point. And that's it. I hope this was helpful. If you haven't done this before, I hope it looks like it's not too bad. I do think this is a good exercise, as it really makes explicit to you what's happening. And pretty soon you'll know better about what you want, and not just blindly trust your IDE, which probably sucks. It also reveals some of your system's architecture in the form of dependencies. And I strongly believe you should take control of your build system now, before it is too late and your technical debt threatens to destroy the project. It doesn't have to be with CMake, but just don't let the vendor be in control. Thanks for watching.